Assalamu alaikum. Welcome back to W Schools. Right now we'll be doing practice problem 4.3 using the superposition theorem. Find VO in the circuit of figure 4.8. This is figure 4.8 right here. And now we'll find out the rule of the superposition. The steps to apply it. You turn off all independent sources except one source. Find the output. You either turn off the voltage or the current. Do that active source using. Repeat step 1 for each of the other independent source. Find the total contribution by adding algebraically all the contributions due to the independent source. Now, what we're going to do right now is turn off the current source. This is us turning off the current source, so it's gone right now completely. And what we'll get is they're all in series in this mesh. Make a mesh loop and call it I1. VO would be 2 times I1 in this loop. So it's going to be, we assume it's 2 plus 3 plus 5, each of them I1. 2 plus 3 is 5 plus 5 equals 10, so it's 10 I1 minus 12V, because he assumes since it's coming out of the negative, it's negative. So we put it in the other side for it to be positive. It will be 10 I1 equals 12, which would make I1 equal 1.2. Multiply that by 2, since the VO is 2 and 2I1, and I1 is 1.2, so it's 2 times 1.2, it equals 2.4. Now, since we turned off the current source, now we're going to turn off the voltage source, bring back the current source. When we do that, we have two different loops. What's better is we use the nodal analysis. We got B here, and the nodal analysis, everything coming in equals everything coming out. Just like here. What's coming out of it, we're seeing this VB over 5, which is a series of these, and this is VB over 5, and all equals what's going in, which is 5. So these are them coming out, and this is going in to this node right here. Now, since we got 5 here, we can multiply it all by 5 to simplify it. 5 times 5 is 25. It equals VB plus VB, because the fractions are gone. It becomes 2VB. You divide 25 by 2 and you get 12.5 volts. Using the voltage divide method, VOI would equal to the VB that we just got out, 12.5, times the 2 over 5. Okay. And once you add that all up, and you'll get VOI equals 5 volts. After that, since you got 2.4 volts in the when you turned off the current source, and 5 volts when you turned off the voltage source, what you do at the end is you add them all up. VO will equal VO of the voltage source plus VO of the current source. So it will be 2.4 plus 5, which will equal 7.4 volts. And thank you, that's it for this one. Hope you enjoyed it and hope you learned something.